This is AP Calculus AB, section 2.1, page 4. And we are going to be finding the instantaneous velocity at time equals 3 seconds for the equation that we had on the previous page. So we have an issue though, because we don't have an equation to find instantaneous velocity. We only have an equation to find average velocity. And our problem with average velocity is that we're supposed to have 2 times. We don't have 2 times here. So let's make one up. Let's let time 1, t sub 1, be 3 seconds, and time 2, let's let that be some 3 plus h. So not at 3, but 3 plus h, where h is very, very, very small. But not 0. Now let's find the average velocity between those 2 times. Okay, so average velocity is going to be y at that second time, 3 plus h, minus y at that first time, all over the difference in the times, 3 plus h minus a 3. Alright, let's just think here for a minute. From the previous page, our equation for y was 16t squared. So now we have y of 3 plus h, so that's 16 times 3 plus h, quantity squared, minus y of 3, we just did that on the previous page, 16 times 9, 144, all over 3 plus h minus a 3, that's just an h. Okay, let's go ahead and simplify here. Square out that 3 plus h. We'll have 16 times a 9 plus a 6h plus an h squared minus 144 all over h. Distributing through, we have 144 plus 96h plus 16h squared minus 144 all over h. These 144s subtract out. We have 96h plus, 16h squared. Oh, I can erase that now. All over an h. And if we divide out an h, we have 96 plus 16h. That's the average velocity. But we didn't want average velocity. We wanted instantaneous velocity. Since h is close to 0, we can do a limit. Let's let h get even closer to 0. And when we evaluate this limit, we get 96. And again, units. This was position, change in distance, which was feet, over change in time, that's seconds, so 96 feet per second. That's instantaneous velocity. So to find instantaneous velocity at this point, we'll have to make up a second time and work through average velocity, get to the end of average velocity, and do a limit as h approaches 0 to find our instantaneous velocity. Thank you for joining me.